So, a funny fact about bridges, when a bridge is constructed and when it's engineered, it's designed in such a way to be able to actually flex a little bit and to sway a little bit. So, if there's big winds or if there is any sort of stress placed upon the bridge, it can actually absorb some of that instead of taking the impact entirely. It can actually diminish the hit of the bridge because it can sort of absorb it and it can flex and then it can go back to its natural state. Now, when something doesn't have that flexibility, when it's built too rigid, what they discovered is that if the bridge is too rigid, has no ability to flex, which we might sort of assume is a better thing if you want to build a nice solid bridge, or it's something that will stand the test of time and be safe. Intuitively, we might think that we don't want this to be flexible. We want it to be solid, right? And there's some truth to that too. We don't want this thing to be made of jello. But if it's too rigid, then what can happen is the stress that is placed upon it through gusts of wind or lots of weight placed upon it or whatever it might be. What happens is when it's too rigid, it can't handle those changes and it can actually cause it to break. It can kind of like when we think about a piece of glass versus a piece of jello, right? The glass is very brittle in the sense that it can shatter. That stress gets distributed throughout the whole system of the molecular structure and sends a shock wave through it, and it can't handle being in any other states without shattering. That's the issue with rigidity.